So if we're just talking about standard analog signals, we quite often need to convert from one signal type to another. We quite often need to convert from pressure into current. So converting from pressure into current, we use a P to I converter. P for pressure, I for current. Similarly, pressure into volts, P for pressure, E for volts. Current into pressure, I to P. Volts into pressure, E to P. To go from current into voltage, we use a 250 ohm resistor. The reason for that is because we have this equation. Oops, wrong equation. V equals IR. So there is a relationship between voltage and current, and that relationship tells us that R equals V over I. V, in our case, is 1 to 5 volts. So if we take the lower range of that, it's 1. And I, in our case, is 4 milliamps. So if we take the lower range of that, it's 4 milliamps, which is 4 times 10 to the minus 3. And 1 divided by 4 times 10 to the minus 3 is 250. Instruments, generally speaking, milliamp instruments, come in two types. What's called the two-wire or loop-powered instrument. They draw, the power to actually run the instrument is drawn off the 4 to 20 milliamp line. There needs to be a 24-volt supply in series with the milliamp loop. Or you get the four-wire instruments, sometimes called sourcing instruments, and they are supplied with a separate voltage, and the voltage for the milliamp loop comes from the instrument itself. So they have an external 24-volt supply, but it's not in the milliamp loop. Rules for wiring milliamp loops: you wire all the current type devices in series, and that would include the power supply for two-wire devices and any 250 ohm resistors you're using. And then you wire all the voltage devices across any 250 ohm resistors, because of course you use 250 ohm to change current into voltage. Loop-powered instruments, which are called two-wire, they basically behave like a variable resistor. Four-wire instruments, they're the source of the 24 volts. So the wiring looks something like this. We come from an external power supply, 24 volts plus, into our instrument. The instrument, to all intents and purposes, yeah, it's all in the book. All of this stuff is in the book for you to look at. I think it's all in the book. If not, these PowerPoints, all of these PowerPoints I'm going through now, they will be in the software pack that we send you. So we're going to send you, when you enroll, we send you a book and we send you a software pack with all these PowerPoints and any videos we've got as well. And absolutely, it's about 4 gig of books and free information which we send you. So we come out with 24 volts at this point, plus 24 volts. The instrument, to all intents and purposes, is a variable resistor. Why don't we just draw that in? So we come out of the instrument and we're still positive. We're signal now. We go into the positive part of a PLC. We go across the PLC and come out. Now in this case I've got a voltage device, which is a charge recorder. Because I've got a voltage device, I'm going to stick a 250 ohm resistor in. I go across my 250 ohm resistor and I'm back to my power supply. I have a loop. I must have a complete loop for current to go round. Inside the PLC, in almost all cases, we actually have a little 250 ohm resistor. So inside of here we've actually got a 250 ohm resistor in most cases. If you want to talk heart to your instrument, which is what we'll be doing in the pracs, then you need to connect the heart across the instrument. Now, it turns out that power supplies have got things inside them, filters and stuff like that, which are specifically designed to remove any AC component from the DC power. The problem with heart is FSK. FSK is modem, old modem talk, old telephone modem. So where your old telephone modem used to go beep boop beep boop, that's FSK. So it's an AC component. So what we have to do is we have to somehow separate the heart signal from the power supply. To do that, we use a 250 ohm resistor. And the most convenient 250 ohm resistor that we find is on the input circuit of a PLC. So we just do that just to give the instrument a little bit of load, but mostly is to give us a little bit of separation between our heart signal and our power supply. Otherwise, the power supply filters will just remove the heart signal from the line here. A 4-wire instrument. With a 4-wire instrument, we just wire the 24 volts into the instrument, and then the milliamp signal comes out like this, just goes around in this loop. In this case, I've got a chart recorder, so I put a 250 ohm resistor in. It's not necessary if I don't have a chart recorder, but I've gone round 250 ohm to give me 1 to 5 volts, and there's my milliamp loop, and the milliamps go round. My power supply is separately wired into my instrument. The way you can tell a 4-wire instrument from a 2-wire instrument is by the number of wires coming out of it. That's a dead giveaway. For a 4-wire instrument, the minimum wiring is this. Once again, we just use, in this case, we're just using the 250 ohm resistor in the PLC just to give it a little bit of load. It's best to give it a little bit of load so that it has some resistance built into it somewhere along the line. With a voltage type instrument, a 1 to 5 volt type instrument, the most important thing is that everybody agrees what the 0 volt reference will be. In order to make this happen, you have to connect the 0 volt reference on the PLC to the 0 volts on the power supply. This way, the PLC's 0 volts is the same as the power supply's 0 volts. If you don't do that, the PLC's 0 volts can float up and down. And if the PLC's 0 volts floats up above 5 volts, then you won't be getting 5 volts. So the signal goes wrong. So a sure sign of not having tied the 0 volt reference across is that the valve actuator, or whatever it is you're controlling, the instrument, just goes crazy, just does whatever it wants. So if this instrument was a valve, you'd send it 5 volts and it may not open. Other days, maybe if it was raining, you'd send it 5 volts and it would open. And it's a really weird fault where the valve opens and closes according to the weather, according to where the 0 volt reference happens to be floating today.